Example number 9, solving to find an inverse with radicals. We want to find the inverse of the function f of x, which is equal to 2 plus the square root of x minus 4. So the first step is to write the original function, f of x, which is equal to 2 plus the square root of x minus 4. And then we're going to replace in step 2 f of x with y. So we're going to replace f of x with y. So y is going to equal 2 plus the square root of x minus 4. Now in step 3, we're going to interchange x and y. So now the y becomes an x, and the x now becomes a y. Now in order to do that in step 4, now we need to solve for y under the radical. So by doing that, the first thing we want to do is we're going to subtract 2 from both sides of the equation. So we get x minus 2, which is equal to the square root of y minus 4. And then we're going to use properties that we learned earlier in our sections. We want to get rid of this radical by squaring both sides to remove the radical sign. So we end up with x minus 2 squared, which is equal to y minus 4. And now we want to solve for y by adding 4 to both sides. So y is going to equal x minus 2 squared plus 4. Now we can rearrange this so that y is on the left side and the other part is on the right side. So y is equal to parentheses x minus 2 squared plus 4. And then we're going to replace y with f inverse of x, which is equal to x minus 2 squared plus 4. Now the domain of f is 4 infinity. And notice that the range of f is 2 infinity. So this means that the domain of the inverse function is also 2 infinity. So what you can see here is that if we come back up here, okay, what we can say is, what is the domain of this function? Going back to what our statement from our last statement there, we can see that the domain abbreviated here, okay, is 4 to infinity. And the range is 2 to infinity. Now, when we find the inverse, these two flip. So what that means now is for the inverse function, the domain now becomes the range from the original function. And now the range is the domain of the original function. So the formula we found for f inverse of x looks like it would be valid for all real x. However, f inverse itself must have an inverse, namely f, so we have to restrict the domain of f inverse to infinity in order to make f inverse a one-to-one function. This domain of f inverse is exactly the range of f. Okay, so we've determined the inverse of this function, and we saw that the domain and the range flip for the inverse as opposed to the original function.